Let's talk about abstract equations. They're also known as literal equations, meaning there's two or more variables. You're not solving for x anymore, you're just trying to get the variable by itself. So in this equation, for example 1, we're trying to get c by itself. So this is the conversion for Fahrenheit to Celsius. We want to put it in terms of Celsius, meaning you want the c by itself on one side. Looking at this, we want the c by itself on one side. We're moving everything on that side to the other side. So anything adding or subtracting, I'll go ahead and move it. So f minus 32 is equal to 9/5 c. From this point here, I need to get the c by itself. You could multiply by 5 to both sides and then divide by 9 to both sides. The easier way, multiply by the reciprocal. So multiplying this side by the reciprocal, multiplying this side by the reciprocal. I end up with 5/9 times f minus 32. You're not going to multiply it out. You're going to leave it like that. 5/9 times f minus 32, and that's how you get the c by itself. We're not plugging anything in just yet, but we're just trying to solve for it. Example 2a, same thing. This whole lesson is just dealing in different ways on how to get a variable by itself. Here, we have the surface area here, but we want to solve just in terms of h, meaning we want the h by itself on one side. So here, we have two terms on this side. I'm going to go ahead and move one of the terms over. So the h is right here. I'm trying to get this h by itself. I'm going to move this over to the other side. So I'm going to subtract minus 2 pi r squared to both sides. You can't really combine them, so I get s minus 2 pi r squared is equal to 2 pi r h. And if you look here for this h, all four of these factors are multiplying. So you could divide one at a time, it just makes it more complicated. Just divide all of them. So I know the 2 is multiplying into the h, the r is multiplying into the h, and the pi is multiplying into the h. So I'm going to divide both sides by the 2 pi r. So remember, you have to multiply all of it all together. So then my answer for h is equal to s minus 2 pi r squared over 2 pi r. Get the h by itself, that's all they want. And then everything cancels out here. And then h is by itself there. B, we have h is equal to 1/2 of gt squared v plus v o t plus h sub o. We're going to solve for t. If you notice here, everything is in terms of a quadratic equation. So t squared, t, and then the constant. So what we're going to do is we're using the quadratic formula to solve, for example, b. First thing we do, we move everything by itself on one side. According to the quadratic formula, one side has to be 0. So the h's, I'm going to combine the h's here. So then I have 0 is equal to 1/2 g t squared plus v sub o t plus h sub o minus h. From this point, I'm going to identify all my a, b's, and c's. A is the number in front of t squared. It's 1/2 g. So a is equal to 1/2 g. B is equal to the number in front of t, which is v sub o. So it's like a small o. And then c, my constant, is actually this whole expression here. H sub o minus h. It looks very complicated, but just take it step at a time, just like you would for numbers. Quadratic formula. I'm going to put it here, minus b plus or minus square root of b squared minus 4ac divided by 2a. If you don't remember, just look it up. It's everywhere on the internet. Now, we're trying to simplify this because we want t by itself. We use quadratic formula to get what x could be. In this case, our x is now considered our t's. Our t is t squared, t, and then just a constant. So to solve for t, we're using the quadratic formula. So negative b minus v sub o plus or minus the square root of b squared, and that is v sub o squared, minus 4 times a. A is considered 1/2 g, times c. C is h sub o minus h. Divide this all by 2 times a. A is 1/2 g. So you're going step by step, and you're plugging in what you need to know. Try to include your parentheses as much as you can, because it will make it a lot more complicated if you don't. Now, let's go ahead and simplify. Negative v sub o, you can't simplify that. Underneath the bracket, you can. So v sub o squared just turns into v sub o squared. Minus, if you notice, we have a binomial here, so we can't really do anything here, but we can multiply the 4 1/2 g. 4 4 times 1 half g is considered 2g times h sub o minus h over 2 times 1 half g, just g. And the last step, if you leave it like this, I would count this as a correct answer. But they're saying let's simplify even more. Let's go ahead and distribute the negative 2g over here. So to do that, our t is equal to negative v sub o plus or minus v sub o squared minus 2g ho plus 2gh. I'm using distributive property to distribute that out. So when I do that, everything's over g, and this is what t is. Example 3. This is where it gets a little bit more complicated because they have the same variable. There's actually 3 different types of r here. There's r sub 1, and r sub 2. So there's 3 different types of r. They only want us to solve for r1. So here we have a complex fraction. We have to go back to the basics. Complex fraction, we want to get rid of it. To get rid of it, solve r1. I'm going to go ahead and multiply, just focusing on the denominator here. I'm going to multiply by the least common denominator. The least common denominator would be r1, r2, like multiplying the 2, r1 times r2. So on this side, I will need to multiply this one by r1. This side, I need to multiply by r2. When I do that, I get r equals 1 over r2 plus r1 over r1, r2. I multiply it across, I get the same denominator. I multiply across, I get the same denominator, and I add the numerator. So that's why I got r2 plus r1. Now I have r is equal to 1 over this whole thing. It's a complex fraction. Multiply the top and bottom by the common, or by the denominator. So the reciprocal of that would be r1, r2 over r2 plus r1. Be careful if you're multiplying your addition. So these two are multiplying. This one's multiplying, this one's adding. Do the same thing on the numerator. r1, r2, they were multiplying over r2 plus r1. Now, 1 times that whole thing, I get r is equal to r1, r2, r2 plus r1. So they're adding. Take it step by step. Here, what you could do, one of 2 ways the book has it, that you find the common denominator, you multiply both sides, and then cancels out your denominator. What I'm going to do gives you the same answer too. I'm going to go ahead and make r as a fraction, r over 1. Whenever you have 2 fractions that equal each other, you cross multiply it out. So when I cross multiply it out, I get r, move over here, r times r2 plus r1 is equal to 1 times r1, r2. So I get r1, r2. There's an r1 on this side, there's an r1 on this side. We have to make sure we can move all the r1s at least on one side. Here, I can't really move it because the r is multiplying into it, so let's go ahead and distribute the r. When I distribute the r, I get r squared. Remember, r squared are 2 separate variables. It's like x and y. You can't just combine them. They're completely separate. Plus r sub 1. Again, x and y, z, they're all completely different. For this, I try to trick you by putting 1, 2, and just by itself. So now I get r sub 2 plus r times r1 is equal to r1, r2. Let's go ahead and move all the r1s on one side because that's the main point. We're trying to get the r1 by itself. If I subtract both sides by r1, r1, you can't really combine them because this one has r1, r2, this one has r1. There's no like term whatsoever. On the left side, I have r2 is equal to r1, r2 minus r1. If you notice, they have a common factor I can take out. Just like 4x plus 6, they have a common factor of 2 I can take out. Same thing here. I can take out an r1. So left side stays the same, r2. If I take out the r1, I get r2 minus r. And to get the r1 by itself completely, you divide both sides by that binomial. So r2 minus r. r2 minus r. When I do that, I officially have r1 by itself. They can't cancel out. Remember, when you're adding or subtracting, they're like married. You can't really cancel anything out unless you cancel the whole binomial out, but you can't. So now this This will be our answer. R1 is equal to R2 divided by R2 minus R. And that's your answer. Example 4. So we're continuing on with this. Example 4, we have a formula for lateral surface area. We have to solve for H. So we have a couple things going on here. We want to solve for H. H is underneath the radical here. First thing you do, we want the H by itself, so it's underneath the radical. So it looks like pi and radius, pi and r, is multiplying into that factor. So now, if I divide both sides, I get r squared plus h squared is equal to L over pi r. To get rid of the square root, we have to undo it. To undo it, we square both sides. When you square both sides, I have r squared plus h squared is equal to L squared over pi squared r squared. Whenever you square something with a fraction, you square every factor on that fraction. Now, looking at this, to get the h squared by itself, we can move over the r squared. When we do, we have h squared. Let me bring down a little more. H squared is equal to, we have L squared over pi squared times r squared minus r squared. You don't combine it to anything there. So this was adding term, this is a fraction here, multiplying into pi, cannot combine them. Last thing, we want the h completely by itself. It's squared, so we square root it. So we square root all of it. And when we do, we have h is equal to the square root of L squared over pi squared times r squared minus r squared. And that would be your answer. Last one, example 5, and we're done. Here we have, looks like a cylinder. We have the volume being 2400, and we have the height being 25. They said, what is the radius? What's the approximate radius of this shape here? So let's go ahead and create a formula, and all we have to do is just plug in what we know to solve for r. So here we have this formula. This is the formula for the shape. To get the r by itself, I go ahead and divide anything that's multiplying into it. In this case, it's pi and the height. So when I do that, I get v over pi h equals r squared. The r isn't by itself. You have to square root it to get the r completely by itself. So you square root both sides. You have r is equal to that whole thing right there. The square root of v over pi h. So now, let's go ahead and plug in what we know. So the square root of v over pi h. The volume is 2400. Pi is just pi. H, our height, is considered 25. I prefer having the number first for that. And then that's equal to our radius. So all we have to do is just plug in and solve for our radius. So if you do 24 divided by 25 pi, if you work a different way in your calculator, it will actually give you like 300 and something. So what I do, I did 25 times pi. I got some number, I forgot what it was. But I got that, and then I divided 2400 by that number that I got. So when I did that, I got 30.55. Again, if you get 300, that means you did it wrong. I think the calculator reads it as you divide first and then you multiply by pi. Unless you put parentheses, 2400 divided by parentheses 25 times pi, and then you'll get it right. Then go ahead and square root it, and you'll get about 5.5 for the radius. And if you want to double check your work, if you plug everything back in, your answer should be around 2400, like very closely, and that's how you can check. If you need any more help, make sure you let me know by emailing me. Make sure you guys have a great day.